Hello, this is Grant Kim, and welcome to my Physics 2212 Lab Report 4. And now, I will introduce the lab. The objectives of this lab are to measure the distance dependence of a magnetic field due to a bar magnet, and then compare this distance dependence to values derived from the Biot-Savart law. The fundamentals of this lab are understanding the relationship between the magnetic field versus distance, that is, the strength of a magnetic field decreases as distance increases. We also need to understand the magnetic field of a dipole equation, shown here, as well as the Biot-Savart law. A preview of the results showed that the magnetic field does indeed decrease as the distance increases. However, the experimental and computational values received in this experiment differ. The n value we got was negative 2.0132, the k value e to the power of negative 13.368, and mu as 4.3298. These values and what they mean will make more sense as we get into the experiment itself. And now for the experiment itself. The materials we need for this lab are a smartphone with a magnetometer app, a bar magnet, a meter stick, and some tape. The assumptions going on this experiment are that no other magnetic fields are acting on the experiment, and the x-axis is defined by the axis of the width of the phone, and the y-axis by the length. The objective of the experiment is to observe how the magnetic field generated by the bar magnet interacts with the magnetometer on the phone. The starting conditions are the magnet is laid at the end of a meter stick, and the phone is laid at the opposite end. The system is the phone and the magnetometer, while the environment is the bar magnet and everything else. The procedure involves aligning the magnetometer to the north-south axis, finding the distance from the magnet that makes a magnetic field with a magnitude of R20, and repeating this 3 times to make sure the values are consistent. We then repeat this procedure 3 times for magnetic fields with magnitudes R70, R120, R170, and R220. Then, we change the experiment slightly and repeat for off-axis measurements. So we set up the phone and the magnet in such a way that it creates a 45-45-90 triangle, as shown in the figure below. The expectations of this experiment are that the magnetic field should decrease with distance, and the experimental and calculated fields should be similar or equal. However, the experimental magnetic field is larger than the calculated magnetic field. The slope, which is equal to n, is negative 2.0132. The intercept, which is equal to log natural of k, is equal to e to the power of negative 13.368. R is equal to 0.1193, and mu is equal to 4.3298 via the Biot-Savart law. The slope and the intercept come from the graph, which is shown on the slide here. Here is a representation of the experiment created in GlowScript. The code is linked in the description, and the code has notes as well, so you can find descriptions and what the code means there. And now for the conclusion. Potential sources of error for this experiment include foreign electrical and magnetic interference that could come from anything, from electrical devices to simple metals around the smartphone in the experiment area. Another potential source of error is bumping the smartphone while conducting the experiment and throwing off the alignment created at the start. And now for a few following questions. What if we hadn't oriented the experiment to compensate for magnetic north and had instead laid out the meter stick at some intermediate angle with respect to Earth's magnetic field? How would the results have changed? Well, the x component would have changed, thereby changing the n and k values. And this would have led to an even greater divergence in the calculated and experimental values. What if we were to stick two identical magnets together, end to end, and run the experiment again. How would the measurements differ? Well, the magnitudes would double due to superposition, but the directions would not change. Only a difference in the magnitude of the magnetic field would be observed. This concludes my experiment and lab report, and thank you for watching.